Okay, now we are doing to alkane. What is alkane according to you? Tell me, what do you mean by alkane?
Single bond.
Single bond or double bond?
Alkene या alkane?
Alkene. We done with alkane.
Double
Now,
bond.
yes, it will be what? A double bond. What it will be have double bond. So when you talk about the alkene, alkene, Kene, that is represent the carbon-carbon and double bond. So always remember the alkane start with a methane, but definitely to start to the alkene, you need a two carbon. So it start with a ethene. This point is very much clear because it require a two carbon. This point is very much clear. Yes.
Hmm.
Okay,
Yes.
that we have done. Well done. So that point is very much clear to us. Okay, fine. Now, when you talk about the alkane, alkanes are unsaturated hydrocarbons. What is unsaturated? They can be a double bond. Obviously, they are double bond. See, if they have a triple bond, that will be alkyne. But right now, we are only dealing with the unsaturation having the double bond. That is termed as a alkene. Okay, carbon-carbon double bond is there. And general formula is okay. What is the general formula for alkane? Can you repeat? CnH2n plus 2. Yes, isn't it? Isn't it?
Yes.
Okay. So, when you talk about the formula for the alkene, okay, what it will be? CnH2n
H2N.
plus 2 is not there because, see, when I talk about the this, which structure I'm drawing, can you tell me? Which structure is this? Bacha, tell me.
Methane.
Is it methane?
Ethane. Ethane.
Two carbon. Yes, it is a ethane. If similarly, I want to draw the ethene. So carbon-carbon double bond will be there. Yes, definitely. Now only the two
Hmm.
bonds are remaining for another hydrogen to have the bond with it. Yes. So now, can you tell me how much carbons are there here? C2, H2.
Two.
2 means how? H2 means what? It's not 2 actually. 2N we want, right? We want 2N, right?
Hmm.
We want 2N. But can you tell me how many hydrogens are there? One, two, three,
Six.
four, five, six. Total six are there. So it can be have the formula CnH2n plus 2. If the n is equal to 2, if you calculate that, you obviously will get this formula. But right now, what is the thing? The two, the bond between the carbon is 1 here. But here they have a two bonds. This point is very much clear. They have a two
Hmm.
bonds. So definitely if the two bonds carbon carbon will be forming, they will be lose the hydrogen. And that's why the formula have the 2n because C2H4 will be there where two hydrogens are removed.
The voice is cracking.
Two hydrogens are removed, right? Yes or no? This point is very much clear. Okay, just give me 1 second.
Huh.
Okay, now my voice will be resumed, right?
Yes.
Yes. Okay, just 1 second. Okay, now it's very clear to you. Now, this point is very much clear. What we have done in this case, how the formula we derived. Yes, this point is very much clear.
Yes.
Okay, now let's go to the next point. Okay, please write the formula of ethane is, general formula is this. Please make a note of this. And why minus 2 that you understood. Please make a note of this. Okay, now let's go for the preparation. Okay, I will teach you how the mechanism of that. First, dehydration of alcohol. What is alcohol? Let's talk about this is the alcohol. Can you name this alcohol? Hmm. Can you name this alcohol? This is methanol. Am I audible to you?
Huh.
Yeah.
Yes, sir.
This will be C2H5OH. This will be ethanol.
Ethanol.
All right. Now, from this alcohol, We want to prepare something. We want to prepare what? So let's do, give the heading preparation. Give the heading preparation of alkene. Okay, this is preparation of the alkene. Now first, from alcohol. So let's take alcohol. Let's take C2H5OH. This is your ethanol.
Ethanol.
If you take this ethanol and if you take a concentrated H2SO4, okay, now as you take the concentrated H2SO4, this become dehydration. What is dehydration reaction? Where the water molecule is removed. Yes or no? So this is OH and one H from here. So what you will get? What you will get?
H2O.
H2O will be removed. If the H2O is removed, obviously one bond one this carbon will lose the bond with one bond with hydrogen and one bond with this O. So there are two bonds. And how many carbons are there? Two. So carbon carbon two bond will be forming and it will be form your ethene. Yes or no? Yes. Yes. This point is very much clear.
Hmm.
But I have a doubt. Sir, can we take this into consideration, methanol, to form this reaction? Can we take into this consideration concentrated H2SO4?
No.
No. Why? There will be no reaction. Why? Because carbon
One
only
carbon.
one carbon is there. That is the reason. So you are beautifully understood this concept, and that's very good. So this is a first reaction. Okay. Okay, okay. While explaining you, please make sure you're writing also. So is there any doubt? Shall I move further? This point is very much clear.
Yes.
Okay. Do we require any temperature? Do we require any temperature? Yes. We require a temperature that is 170 degrees Celsius. Okay. That will be mentioned. If there is mention in NCRT, you can use it. Otherwise, this is more than enough. Okay. Now dehydration is there. Now what's the mechanism? What we have mechanism use? The acid protonates OH group forming the water, right? Yes or no? So that concentrated H2SO4 water is what removed. One molecule of water is removed. Yes. Water leaves forming the carbonation. What is carbonation? I told you na carbon carbon will be forming the bond. Two bond will be forming, right? So they need an electron. So how they need an electron? Because hydrogen and OH bond. The O and hydrogen is removed. So two bonds are now what happened with two bonds? They left the bond. So they need to form the another bond. So they form carbon carbon form bond between them, and that is called formation of carbocation. They will be formed that. Okay, there is elimination of the this thing. Mechanism I will tell you later on, but right now let's do only the reaction purpose. So dehydrogenation of alkyl halide. What we have? Alkyl halide. What is halide? Halogen group. Are you agree with this? Yes.
Yes.
For halides, we are using the KOH, alcoholic KOH. We are using what? Alcoholic KOH. See, the halide will be taken care by potassium. Water, obviously, it will be removed anyhow because alcoholic you are using, and your bond will be formed. So CH3, CH2Br. If I'm taking the second reaction, if I'm taking from, let me write here, from alkyl halide, from alkyl halide. Okay, let's take example here, CH3, CH2Br. Okay, what is the name of this compound? Can you tell me what is the name of this compound?
Ethyl bromide.
Ethyl bromide, or we can say bromo ethane. Yes, or we can write
Hmm.
ethyl bromide. One and the same thing. Very good. Now I'm going to deal this compound with KOH, but KOH will be what? Alcoholic KOH. Okay. Now what going to happen? This K will take care of this Br. So what going to happen? Your KBr will be formed. Yes or no? Yes.
Hmm.
Then This is a OH group. This will be the OH group. This OH will take this one hydrogen. Can you see that? This hydrogen, this hydrogen, this hydrogen. See, again, I'm going to tell you. This OH will remove the hydrogen from here because already Br bond has been broken. So this carbon needs
Hmm.
one bond. This carbon have three hydrogen. Out of that, one hydrogen is taking care, or what we can say, it is taken out by this OH. So what happened here? Your water molecule is liberated. Okay, and now this C, okay, now let me write in this manner. So what going to happen here? C double bond C will be formed. Yes or no? Agree?
Ethene.
Ha, ethene will be. Ultimately, we are forming the ethene, but like this. We are forming the ethene like this. This point is very much clear. Yes?
Yes.
Please write this reaction quickly from alkyl halide. From alkyl halide, we are forming this thing. Okay. Make sure you're writing it properly. Chalo. Now we have done this. Now let's move to the next. So see, I will beta elimination E2. I will tell you later on. Right now we are only doing what? The superficial thing very quickly. Then I will tell you what is elimination and all. Okay. Don't worry about the
Hmm.
mechanism. Which reagent we use? Alcoholic KOH. In examination, if I'm right KOH, then your mark will be not given. Why? We need a alcoholic KOH only. Please make sure that. Okay. Okay.
Hmm.
Now, dehalogenation of vicinal dihalide. What do you mean by vicinal dihalide, first of all? Di means two. Vicinal means one carbon is here, one carbon is here. Here is Br is attached, here is Br is attached. I'm not drawing now hydrogen. So this is called vicinal dihalide. Dihalide means how many halides are there? Two. On a different carbon, or we can say neighbor carbon. Can I say that? Can I say that?
Yes.
Okay. So what we need here, we need a zinc in alcohol. What we need? We need a zinc in alcohol, and that is what we need as a first reagent, not reagent, first substrate is vicinal dihalide. So what will be our third preparation? From what should I write? From vicinal halide. From vicinal di, you're getting all the points. Okay, any doubt you can
Yes.
ask me. So here is carbon and carbon. I'm drawing here Br, and definitely remaining part will be your hydrogens. Yes or no?
Hmm.
Okay, now what happened? I have taken a zinc into consideration. Okay, but again zinc is what? Alcoholic. Please remember that zinc will be alcoholic. Now after the reaction occur, what going to happen? Tell me. Zinc will be 2 plus. That means what? Zinc can be reacting with a 2 halide. Yes or no? Yes.
Hmm.
If these two bonds are breaking, definitely one bond will be forming here. Simple, right? Right? So there is a byproduct will be ZnBr2. This point is very much clear. Zinc will be taken care of Br and Br. So this bond is broken down. Now this carbon and this carbon will be formed bond between both of them. So it's C double bond C, right? Br is not there. So hydrogen, 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 hydrogen. Again, we got a ethene. Yes. Any doubt in this reaction from vicinal dihalide? Yes.
No.
Clear? Okay. See, only we are interested in ethene. No, we can make propene as well. There is no issue at all. But right now we are using this ethene as a our ideal alkene. Okay. So that is the reaction. Can you write this reaction? Can you take a note of this? Again, I'm going to tell
Yes.
you alcohol is zinc should be there. This reaction is now easy, right? Yeah, because we
Hmm.
have cleared the basics. Very good. Go ahead.
Done.
Done? Okay, well done. So now let's go to the partial hydrogenation of alkyne. Partial hydrogenation of alkyne. What do you mean by partial? 50%. Hydrogenation. What is hydrogenation? Adding the hydrogen. Alkyne. What do you mean by alkyne? Carbon
Triple
carbon
bond.
triple bond. So you're providing hydrogen. So partial. If you give all the 100% hydrogen, it will become alkane. Be interested into alkene, right? Yes. Yes.
Hmm.
So we have a this thing over here. Okay. So let's convert in a third. What is the fourth reaction now? We are taking into consideration partial. Tell me, partial
Hydrogenation of
hydrogenation, yes, of
alkyl.
alkyne. So ultimately, we are actually converting alkyne to alkene
King.
via addition of hydrogen. But hydrogen is a gas. We need some reagent. We need a Lindar's reagent. What is that? Let's understand. So we have a triple bond. This is called as ethyne. Now we need a hydrogen gas, obviously in presence of Lindar's catalyst. What is that? Again, I'm going to tell you, hydrogen is a gas, right? It needs a
Hmm.
surface. So it can attack on this, and the double bond, triple bond will be get addition of the hydrogen. Okay. We have a control. This is what partial. Okay, partial. So that's why we need a this Lindar catalyst. So what happened? Two hydrogens will be added. So it become now CH2 double bond. CH2 simple. What's the name of this? Ethene. This point is very much clear now. Easy. Okay, that is a Lindar's catalyst is there. Okay, can you just write this first? Okay, you don't worry about what is there in a Lindar catalyst. Okay,
Okay.
just understand that Lindar catalyst is used for because hydrogen is gas. Gas is not reactive until unless it gets the surface, right? So that is the thing.
Hmm.
Okay, yeah.
Is it DAR or DER?
Mm-hmm. Lindar,
DAR.
AR, Lindar.
Done.
Done. Now let's move to the very important part, that is your Kolbe electrolysis. What do you mean by electrolysis? We have a cell where electrode are there, positive and negative, cathode and anode will be there, electricity will be passing from there, and the bubbles will be formed on cathode and anode. Okay, that is electrolysis. Got it? What is
Hmm.
electrolysis? Okay, very good. Now, in Kolbe's electrolysis, this is a super important question. Okay, then super important reaction. So, first I will teach you here what they have written. Then I will make sure I will write in a separate part. So, let's understand here. So, what is this CH3COONA? What is this? Sodium salt of acetic acid. Okay, sodium salt of acid. Instead of Na, if it is H, it is acid, right? Now that H is
Hmm.
replaced by sodium, so it will be sodium salt of acetic acid. Inside the water they have mixed. Electrolysis means what? Electrodes are deep and like electrons are moving, that is electricity is passed from there. Okay, that is sodium salt of carboxylic acid. Now what happened? I'm not going to tell you the mechanism right now. I'm just going to tell you what happened exactly. So your CH2 is formed. That means from this CH3 COO, we are getting the CH2 bond. This point is very much clear. Yes,
Hmm.
yes. But there is a problem. What's the problem? So we have a 2CH3 that we are forming this thing. But we have an extra carbon that is released in the form of carbon
Carbon
dioxide.
dioxide.
Very good. And so what about is Na? See, water is there. So NaOH will be forming, and extra hydrogen will be liberated. This point is very much clear.
Hmm.
Okay, so simple. What we have, but make sure we have a two molecule of CH3CONA. That is very important. If you're writing one, it's wrong because we need because we are representing the one molecule of formation of the ethene, right? So what we have, CH3CONA. So let me write here where it is. Okay, 4. Now we are going for the fifth one. Okay, you are going to help me. What is the heading for this? Electrolysis. Electrolysis. Or what we can write, Kolbe.
Sodium. अच्छा, okay.
Yes, Kolbe's reaction. Okay, very good.
Hmm.
Now, for that, I need two molecules. You have to remember this, right? CH3, C double bond ONA. Can I write in this format? Yes. Sodium salt
Yes.
of acetic acid or sodium salt. This is carboxylic acid. Yes or no? This is carboxylic acid.
Hmm.
Hydrogen was there, it is carboxylic acid. Now, hydrogen replaced by sodium. So, that is sodium salt of carboxylic acid. But right now, it is used. Now, if I add water, how many water molecule? 2. See, this
2.
reaction is electrolysis, means what? Electricity is used. So we should know that right now we are doing not exactly the mechanism that is not needed right now. So we know that 2CH3 is there. Can you see that this CH3? We are going to
Hmm.
form out of this CH2 double bond CH2. We got form ethene. Yes, this point is very much clear.
Hmm.
Very good. Now we have this extra this thing. What will be liberated? CO2 will be liberated. Yes or no? Yes.
Hmm.
Then, so we have sodium. That is,
Sodium hydroxide.
yeah, sodium hydroxide. Yes, it will be NaOH will be
NaOH.
there. Anything else will be liberated?
Hydrogen.
Hydrogen will be liberated because extra one thing there. So hydrogen will be liberated. Why this is very important
Hmm.
reaction? Because we are getting hydrogen as well. We get the two products which is required. Three products actually. Don't you think so? Everything is commercially useful. Ethene,
Hmm.
NaOH, CO2, and H2. That's why Kolbe's electrolysis process is more preferred, and that is very, very important. Okay. Yes. So let's count the carbon. Or 2 carbon, 3 carbon. 2 carbon, 3 carbon. Yes, balanced? Yes, that is the
हाँ.
thing. So please write this reaction. Understand this? This is reactions is occur in a container. Okay. So this will be your H2O. Okay. That deep into what? These are the electrolyte positive. Okay. And this will be a negative. And again, they will be connected by obviously battery, right? So what is
Hmm.
happening over here? This is H2O along with your CH3CONA. And when the electricity pass, there be formation of the bubbles on the cathode and the anode. This will be liberated. CO2 gas and H2 gas will be liberated along with formation of this. This point is very much clear. Okay.
Yes.
Okay. This point is very much clear now. Okay.
Done.
Okay, bacha. Very done. Now, let's talk about a chemical reaction. This much are chemical reactions are there. I will teach you the important part. Very, very easiest one are there. So I will use this notes only. Okay. Now, I will give the worksheet after this. You have to solve it. Okay. So combustion. What is combustion? Addition of oxygen.
Hydrogen. Okay,
Okay.
oxygen.
Oxygen. Okay. So when you add the oxygen, definitely a bond is leaving. Why bond is removing or bond is getting destroyed? Because it's a combustion. So oxygen is getting added. You get 2 CO2. How many alkenes are there? 2 carbon alkene. So how much amount of carbon dioxide you get? 2 carbon dioxide. Are you getting my point? Yes.
Hmm.
Yes. Okay. So
Yes.
you'll get along with the water and the heat. This will be a exothermic reaction. Why? Because heat is liberated.
Hmm.
Okay, can you write this quickly? Only the reaction. Okay, they have written complete combustion give the CO2 and H2. Complete combustion means what? Completely oxygen is getting attack on this. Okay, and incomplete combustion, it will give carbon monoxide. That is partial one. but we are interested into this. Okay, so please write this. Okay.
Second.
Okay, let's move further. Don't worry, I will give you these notes. Don't worry. Okay, now let's move. Addition of hydrogen. Now tell me one thing. Hydrogen is a gas, right? It is a gas. We need a
Yes.
surface. We need a rough surface. So this hydrogen molecule will be attached on these grooves of the surface, right? And the reactant come and then will we have a reaction. So hydrogen gas, somebody has to be captured and then it allowed to react with another thing. Yes, this point is very much clear. So we need a catalyst such as a nickel, platinum, and palladium. Please remember that. Hydrogenation needs a surface catalyst to capture the hydrogen molecule that makes sure reaction will be occur smoothly. Otherwise, you have a gas and you have a reactant. They will not react because there is no contact. We need someone forcefully picking up the hydrogen and making sure the reaction will be occurring. This point is very much clear. Yes. So,
Explain again.
I will explain now. Now tell me one thing. CH2 and CH2 double bond is there. I need
Hmm.
to add hydrogen into this thing. But
Hmm.
hydrogen is what? Hydrogen is a gas. Yes or no? It's a
Hmm.
gas. So I need something called as catalyst to speed up the reaction. Okay. To speed up the
Hmm.
reaction as well as to make sure this is happening again and again. So we need a surface catalyst. Surface catalyst such as nickel, then your platinum and your palladium. So
Hmm.
what they do, this is the surface catalyst. They have a surface. They provide the surface because gas is their hydrogen. You have this thing which is already present, but hydrogen has to be entrapped. Yes or no on the surface. Then only this reaction will occur
Hmm.
smoothly, and then hydrogen getting added on that. Yes or no on this. So we'll get ultimately CH3, CH3. Got it? So we are
Hmm.
converting, we are converted alkyne, sorry, my mistake. Alkene
Alkene.
to alkane. But you need a surface catalyst for sure. This point is very much clear. Now,
Yes.
okay. Then addition of halogen. Let's do this till this here. Addition of halogen is what? See, you have a CH2, CH2. You need to add Br over here. You just need to add Br over here, right?
Hmm.
So simple, simple. How simple? See, they break the bond between one. If this is a double bond, right? Okay.
Hmm.
They remove one bond. This means this carbon and this carbon have now vacant bond. That will be reacting with Br and Br. This is called as vicinal dihalide. Do you remember? From vicinal dihalide, we prepared that. Now, right now, we're also making the vicinal dihalide again. Yes?
Hmm.
Okay, fine. That point is very much clear. Now, the last one. I will teach this next addition of hydrogen halides in next class. Okay. Now, whatever we have done up till now, I'm going to give the worksheet. Okay. So, we'll do accordingly. Just give me 1 second.